Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So yeah, today's question is count good arrays, easy version. In this question, we're given an array A of size n where n is always even and the array A is said to be good if it is possible to choose a continuous cyclic subarray of size n by 2 and then multiply all the elements of the subarray by minus 1 to make the total sum of the array less than 0. For example, if our array A is 1, 2, then it is good because we can choose the element 2 and multiply it with minus 1 to get this array. And the total sum of this array is minus 1, which is less than 0. Hence, this array is good. While this array 1, 1 is not good because irrespective of which subarray we choose, the total sum is always going to be 0. Hence, it is not a good array. Further, this array is also a good array because we can choose the cyclic subarray this one, which is of size n by 2, and we can multiply it with minus 1, and our total sum after that is going to be equal to minus 6, which is less than 0. Hence, this is also a good array. Now, in the question, we are given an even integer n and a binary matrix m consisting of only zeros and ones of size exactly n into n, and we want to count the number of arrays A of size n that satisfies the following conditions. So the array A must be good after substituting the values. All the elements of A should be in between 1 and n, and this condition should also be satisfied. Now, what does this condition says? M of I, A of I must be equal to 1. So for the ith row, for the ith index, whatever element we are putting in must be equal to 1. So to demonstrate that, let's say we have this as our matrix M. So if this element, these are the indices 1, 2, 3, and 4, right? So if this is 1, that means we can put on a 1 at our index 1. And if it is 0, that means we cannot put a 1 on index 1. So for example, this is our final array A. And for index 1, the possible candidates are 1 and 4. So we can put either a 1 or a 4 at this index. For index 2, we can put a 1, 2, 3, and 4. We can put any of the 4 indices. For index 3, we can only put a 1 over here. And for index 4, we can only put a 4 over here because this is the only element that is 1. So yeah, this is pretty much the problem statement. Now let's look at the constraints once. So we are given that the number of test cases would be in between 1 and 1000. The value of n would be in between 2 and 100. The n is always going to be even, and this is going to be a binary matrix. And the sum of n square over all the test cases does not exceed 10 raised to the 4. So we can like have even like n square solution or even n raised to the 4 solution, right? Because n raised to the 4, the sum of n raised to the 4 would be almost like equal to 10 raised to the 8. So we can have a solution of like something of these orders, right? Now the only prerequisite to solve this question is combinatorics. And now let's move to the sample input. So let's say these are the sample input given to us. So in the first input, we have n equal to 2 and m is 1, 1, 1, 1. So now the four possible arrays which we can get are 1, 1, 1, 2, 2, 1, and 2, 2, right? And we can easily see that this array does not satisfy our condition, so it is not a good array. This is also not a good array because irrespective of which subarray we choose, the total sum is going to be 0, right? And both of these are good subarrays, and the total number of good subarrays are 2, so our answer is 2. In the second input, we have 1, 0, 0, 0. And as you can see that we have no possible candidate for index 2, right? So we cannot put anything on index 2. So what are the possible number of arrays? 0, right? Now for the third input, we have 0, 0, 0, 1, 1, triple 0, 1, triple 0, and triple 0, 1. Now the only possible array which we can create for this is 4, 1, 1, 4, right? Because the first element can only be 1, the second element can only be 1, the third element can only be 1, and the fourth element can only be 4. Now this is a good subarray as we just saw in the problem statement, so the answer is 1, and hence this is the only possible case. Like we cannot create any other possible case. Now let's also see like this last test case. Here we have triple zero one, 1001, 1010, and 0010. Now the first index is fixed, it has to be 4. The second can be either 1 or 4. The third can be either a 1 or a 3, and the third index has to be a 3, right? So if we consider all the four possible cases, we'll see that all the four possible arrays which we can form are good sub-arrays. Hence the answer is 4. You can just put in all these values and just verify it yourself. And you can just try like these two test cases I'm not gonna explain because the answer are like really big. So now we'll just move to the solution. So yeah, when is an array A bad, right? When is like let's say we are given some array with some elements. How can we like conclude if this array is bad or not, right? So let's consider this array A, right? This is our array A with 6 elements, right? Now we can choose a subarray of size n by 2. That is, we can choose a subarray of size 3, right? So we can either choose this subarray, right? Or we can choose this subarray, or we can choose this subarray, or this subarray, or this subarray, right? One second. So, or we can choose this subarray, or we can choose this subarray, or we can choose like this subarray, right? So these are like all the possible subarrays which we can choose. So I've just written them down. So either we can choose this 1, 2, 3, and 4, 5, 6, or we can choose 2, 3, 4 as our first subarray, and the remaining one would be 5, 6, 1, right? Or the third possible case is we can choose 3, 4, 5, and the other subarray would be 6, 1, 2, right? Or we can choose like 4, 5, 6, and the other subarray would be 1, 2, 3. And after that, they'll just start repeating themselves, right? Now, when will the subarray be bad? When both of the sum of this is equal to the sum of this for all the possible subarrays, right? Because if they're not equal, if let's say this is not equal to this, then we can choose the subarray with greater sum and multiply that with -1. And then the total sum would be negative, right? That would be less than 0. So for the sum to be equal to 0, right? For the total sum to be equal to 0, this sum has to be equal to this sum, right? Now here we can see that here we are adding 1, 2, 3, 4, 5, 6. Here this 2, 3 are same. Here this 5, 6 are same. The only elements which have changed are 1 and 4. Right, so 1 and 4 have to be equal so that the total sum remains 0, right? Like each subarray remains equal, and if we multiply it with -1, any of the subarrays with -1, then the total sum becomes 0. In the second one, we have 3, 4 same, and here we have 5 and 2. This is the new element, right? Here 3 both are there, 4, 4 both are there, 5, the 6 one in both of them are there, 5 and 2. This is what have changed, right? So array of 2 has to be equal to array of 5 so that the sum remains equal, right? And similarly, array of 3 has to be equal to array of 6 so that the sum remains equal, right? So if in general, if we have a of I equal to a of I plus n by 2 for all the possible values of I, then it would be a bad array, right? Because we cannot choose any cyclic subarray such that their sums are not equal, right? So how can we like solve this now, right? So what we'll do is we'll count the number of bad subarrays that we can have, and we'll also count the total number of arrays which we can have, and we'll subtract total minus bad to get us good subarrays, right? Now, first of all, let's see how we can calculate the total number of possible arrays. So let's say this is our matrix M, where M is equal to 6. Now the possible candidates for the index 1 are 1, 2, 4, and 6, right? So we can put a 1, a 2, a 4, or a 6 at index 1, right? At index 2, we can put a 1, 3, 4, 5, 6, right? So these are the possible candidates for index 2. For index 3, we'll have these possible candidates, right? So now how can we calculate the total possible arrays which we can create? It would be the the number of elements we can place at index 1, that is 4, into the number of elements we can place at index 2, that is 5, into the number of elements at index 3, that is 4, into the number of elements you can place at index 4, that is 5, into the number of elements we can place at index 5, which is 3, into 6, right? Now this is going to be the total number of possible arrays, right? And we can easily calculate this. Now, how can we calculate the total number of bad possible arrays, right? So to calculate that, we want that 1 and 4 both must be 1 so that we can put that together over there. We want this also to be equal, right? So if we count the number of indices where a of I is equal to a of I plus n by 2, then we'll get the count where we can have them equal, right? So let's just start counting. So we can have a 1 at both the indices 1 and 4, right? We can have a 2 at both the indices 1 and 4. We cannot have a 3 at both the indices 1 and 4, right? We cannot have a 4 either. We cannot have a 5 either. We can have a 6 at both of these places, right? So there are three possible candidates for index 1, and index 4 has to be equal to index 1, right? It has no other candidate other than index 1, right? This will be a of 2 only, and this will be of 3 only. Now, what are the possible values we can have at index 2? So this and this are equal, so we can have a 1 at both the index. We cannot have a 2, we cannot have a 3, we cannot have a 4, we can have a 5, and we can also have a 6, right? So these are the three possible candidates for index 2 and index 5. And for index 3 and 6, we cannot have 1, we can have a 2, we can have a 3, we can have a 4, and we can have a 6, right? So we can have 2, 3, 4, and 6. So we have four possible candidates for index 4, right? Now, what are the total possible bad arrays which you can have? It will be the product of them, and this is how we'll get the count of bad possible arrays which we'll be having, right? Now, what is the total good arrays which we'll be getting? That would be total minus bad, and this is exactly what we'll be printing. Now, the only case which we need to handle is handle modulo 1e9 plus 7 properly, and rest we are good to go. So now let's see the solution in C++ first. So yeah, let's say, so yeah, this is our solution. So we'll start by running a loop for each test case, and we'll call this function for each test case. Now in each test case, we'll be taking in the input of n and the matrix m. Now we'll be first of all counting the total number of bad ways. So we have initialized it with 1. Where we're running a loop from 1 to n by 2, and we're counting the possible values of I such that it will be equal to I plus n by 2 inside this count. So if m of ij is equal to 1 and m of I plus n by 2j is also equal to 1, we'll increase the count. We'll multiply the bad ways with count, and we'll take the modulo with mod, where mod is defined as 10 raised to the 9 plus 7. Now we'll be counting the total number of possible arrays. So we'll be running a loop from 1 to n. We'll be counting the count of ones in that row, and we'll multiply our total with that count. And we'll take the modulo, and in the end, we'll be printing total minus bad ways plus mod, all modulo mod, and we'll be printing it with the answer. So yeah, this is pretty much the whole solution. The time complexity for this is n square because we're just running like 2, 3 n square loops. So the overall time complexity is n square. Now let's see the solution in Python. So I will be running a loop for each test case. We'll be taking an input of n and m. We have added this 0, like we're multiplying it with n plus 1 to make it 1 based indexing. We'll be taking in the input of each row. We'll be adding that whole row inside our m, and we'll be adding this 0 to make it 1 based index. Now we'll be counting the total number of bad ways. So we'll be running a loop from 1 to n by 2. And for each I, we'll be running a loop from 1 to n, and we'll be checking if m of ij is equal to 1, and I plus n by 2j is also equal to 1. We'll increase our count, and we'll multiply our bad ways with count, and we'll take the modulo. Now we'll be counting the total number of ways. So we'll be running a loop from 1 to n. We'll initialize count with 0. We'll increase the number of ones in that particular row. So we'll store the number of ones in that particular row inside the count where m of ij is equal to 1. And then we'll multiply total with count and take the modulo. And in the end, we'll print total minus bad ways, which would be our good ways, and we'll print that. So this is pretty much the whole solution. The time complexity is n square because we're just running these 2, 3 loops with of n square time complexity. And yeah, this is pretty much the whole solution. I will end it. Thanks. Bye bye.